So let's talk about rational numbers and irrational numbers. A rational number is a number that totally makes sense. So in other words, all of my numbers, all of my counting numbers, like all of the numbers on the number line, 1, 2, 3, and so on forever, or -1, -2, -3, and so on forever, are all examples of rational numbers. Another example of a rational number is anything that looks like a fraction. Well, I know 1/2. 1/2 is just a number that's someplace that's exactly between 1 and 2. I know that 3/4 is a number that's between 1/2 and 2. So that's 3/4. There's also another example, -5/6. It is a fraction, so it is also a rational number. Any number that I can write as a fraction is rational. These numbers can be written as fractions because all I have to do is put a 1 under them, and they still are the same number. Therefore, they're rational numbers. Well, there's another type of rational number that looks a little bit different. Let's look at it for example. The square root of 4, if I were to plug that into my calculator, let me clear this, and I'm going to say 4 square root. Look, square root of 4 is 2. Well, 2 was an example of my rational numbers. Well, let's try the square root of 9. Plug it into my calculator. I'm going to say 9 square root. That's 3. That's the same as this number right here. So it's also a rational number. Any number that I can get, when I take the square root of it, I get a whole number, is a rational number. Those are the easy ones. However, I get that I say easy and we struggle with it sometimes, but I'm going to show you something. Let me get rid of these because I want to talk about irrational numbers, because those are the ones that kind of throw us for a loop once in a while, and I get that. I'm going to go ahead and clear my screen completely, and I'm going to go back here, and I'm going to write irrational number. Well, we saw that the square root of 4 equals 2. Well, if we were to put that on the number line, the square root of 4 is just right there where 2 is. Well, let's try the square root of 5. Well, the square root of 5 is just bigger than the square root of 4. In fact, let's see how much bigger it is. Watch what we're going to do. We're going to take 5 square root. Look at that, 2.236. And notice all of those crazy numbers. All of those crazy numbers, whenever I take the square root, this means that it's a non-terminating, non-repeating number, and it's an irrational number. So if it doesn't look like this, it looked like this, 2.23, on and on and on. Those 3 dots means it goes on forever and never repeats. That means it's an irrational number. Well, if I was to put the square root of 5 on a number line, guess what? It's about right here. Guess what else would be here? The square root of 6, the square root of 7, the square root of 8, and then look, now I have the square root of 9. So in between these two rational numbers, all of these other square roots are irrational numbers. So if we looked at this, let's go further down. We see the square root of 6, or we see 6 is also the same as the square root of 36 because I plugged it into the calculator. So that means, let's go to 7, and we're going to say, and we know that 7 is the square root of 49 because 6 squared is 36, 7 squared is 49. So guess what else? That means the square root of every number between 36 and 49 is in here, meaning all of those numbers, square root of 30, square root of 38, square root of 41, those are all going to be irrational numbers. Non-terminating, non-repeating decimals are irrational numbers. So if somebody said to me, where can I locate the square root of 87 on a number line? Well, the first thing I'm going to do is I'm going to open my calculator. And I'm going to say, okay, let's try it. We have 87. We're going to take the square root. Look, that's 9.3. 9.3 is someplace in this area. Well, it's closer to the 9, so there's the square root of 87. And that's how I look at rational and irrational numbers. Let's go back and look at one thing really quick. I want to talk about a different type of rational number, but it's not really a different type of rational number. If I plugged in 1/3 into my calculator, 1 divided by 3, I get 0.3333, and it goes on forever. This is called a repeating decimal. If I can find a number that has a repeating decimal and it goes on forever, this is also rational. So if I plugged in 1/7 or 1/7, 1 divided by 7, notice up here I have 142.857. Look what the next 6 numbers are. Exactly the same. 142.857. This is a repeating decimal that goes on forever. It's a rational number. So if I can find numbers that repeat, they're a rational number.